4.6 half-angle identities. So these are found in your notes here and on your formula sheet, which you should always have handy. They're on number 13, so they're summarized on number 13. Notice we're taking square roots and we have plus or minus. So we're not going to really develop these. We're just going to work with them. Okay. So first of all, it says find the exact value of cos of 15. So you have to go back to those values that you know. So remember you have that beautiful chart memorized. If you don't, it's found on page 151 or 153 of exact values. So we know the cos of 30, 45, and 60. So 15 using half angle identities can be written as the cos of 1/2 of 30. Okay, and then using those identities, cos of 1/2 of 30 is equal to plus or minus 1 plus the cos of 30, which is an exact value you know, divided by 2, all square rooted. Okay, so we're just going to plug that in there. So that is equal to plus minus the square root of 1 plus cos of 30 over 2. Okay, that is equal to the square root of 1 plus root 3 over 2, because that's the cos of 30 over 2. Okay, now what we're going to do is we're going to try and simplify this. So using fractions, we're going to get a common denominator on the top here. We're going to rewrite 1 as 2 over 2. So we're going to get 2 over 2 plus root 3 over 2. Well, we can just factor out a 1/2 and bring it to the bottom. So that's just like 4 on the bottom and 2 plus root 3. Okay, now we're going to take the square root of the top and the square root of the bottom. So this is the square root of 2 plus root 3. The square root of 4 is just 2. And that's as simple as we can get that. We're not going to try and fix this. That's perfectly fine. Okay, so there's your answer, finding the exact value. To check this, you could just, in your calculator, actually type in cos of 15. You're going to get a funky decimal, and then put this into your calculator, and you'd get the same decimal. Okay, a more difficult question here. Given that sine of theta is 12/13, theta is between 360 and 450 degrees, find the exact value of sine of 1/2 of theta, cos of 1/2 of theta, and tan of 1/2 of theta. Okay, so using identities, sine of 1/2 of theta is equal to sine of 1/2 of theta. Sine of 1/2 of theta is equal to plus or minus 1 minus cos over 2. Okay. So it is equal to plus or minus root 1 minus cos of theta over 2. I just want to take a second and analyze this, whether it is actually plus or minus or what we're going to use here. So if we said theta is between 360 and 450, if we take half of everything, so half of 360 is 180, half of 450 is 225. So between 180 and 225, well, here's 180, 225. We're dealing with something right here. So looking at that there, sine is actually going to be negative in that quadrant. So we don't even need to write that positive anymore. We can just move on without it. Okay, so, oh, do I know cos of theta? I don't. I only know sine of theta. So I have to do a little more work. So I can say sine squared plus cos squared theta equals 1, or cos squared theta is equal to 1 minus sine squared theta. You guys have seen us use Pythagoras often here. So cos squared theta is equal to 1 minus 12/13 square. Where did I get that 12/13 from? Right here. Okay. So cos theta, oops, cos squared theta is equal to 13 times 13 is 169. So I have 169 over 169 minus 144 over 169. Um, for 25 over 169th, square rooting 25 over 169th. I'll just do all the steps here. That is equal to 5/13. So we got cos of theta is equal to 5/13. And remember, theta is between 360, which is right here, to 450. So it could be positive. We're just going to leave it positive because that's a large range. 360 to 450. Oh, sorry. 360 to 450 means it's right here. Yeah. So we're going to leave it positive. Okay. So now we can substitute in that 5/13. So this is equal to negative the square root of 1 minus 5/13 over 2. So this is good fraction work. This is 13 minus 5 over 13 over 2. So I just got a common denominator. 13 minus 5 is 8. So this is 8 over 13 divided by 2. Simplified, that is just 8 over 13 times 2. 13 times 2 is 26. 8/26. So that can be simplified to 4/13. And then rationalizing the denominator is the last step. So we get root 4 times root 13. 4 times 13 would be 12, 40, 53. No, that's not right. I did something wrong. Sorry, the square root of 4 is 2. I should just do that. 2 over root 13, and now rationalize the denominator. Okay, so root 13 times root 13 is 13. Okay, so this is my sine of 1/2. There's one answer. So I needed sine of 1/2. Now I have to do cos and tan. Okay, so to do cos of 1/2, just using identities, cos of 1/2 of an angle is equal to plus or minus 1 plus cos of theta over 2. So we're just going to sub in. Again, because of the quadrants in quadrant 3, it's going to be negative. So we get 1 plus cos theta over 2. That is equal to negative root 18/13 divided by 2, or that's the same as timesing by 1/2. Okay, so we have, this is going to be 9. So we have 9/13, which is 3 over root 13. Rationalizing, we get 3 root 13 over 13. Okay, tangent of 1/2. Okay, because it's in quadrant 3, we know that tangent is positive. So we get 1 minus cos over sine theta. Oops. And that again just came from my identities. The tangent of 1/2 of theta is equal to, and I chose to use this one because I knew cos and sine. Yes, I could have used any of these. Okay, why use square roots when I don't have to, though, you know? Keep it simple. Okay, 1 plus cos, so that's, or 1 minus cos, 1 minus 5/13 over 12/13. Okay, so that's like 13 over 13. We could rewrite this as 13 over 13. 13 minus 5 is 8/13. So I have 8/13 divided by 12/13. That's kissing and flipping. That's 13 times 12. Simplified, the 13s cancel out. I have 8/12, which is the same as 2/3. Okay? That was a lot of work using Pythagoras and using identities there. Okay, next page. Is each statement true? So all we're looking at is we're looking at the identities, we're looking at the signs. Okay, sine of 41. So first of all, I look at the number 41 and 82. Yes, those two are half angles. So the sine, this is like saying the sine of half of 82. Okay, so looking at our identities, when we have the sine of half of something, we get plus or minus 1 minus cos of 82 over 2. So is this 1 minus cos? No, wrong sign, so not true. Okay. Next one, cos of 53 and 74. So right away I see 53 and 74, they don't have anything in common. Like they're not double. But wait, I feel like someone's trying to trick me. What is 53 times 2? 53 times 2 is 106. So let's just look at where 106 is. 106 is all the way over here. What is the reference angle of 106 though? So if we have 106, if we subtract 90 from that, then we have 16 here, and then we have 90 minus 16 gives us this reference angle. Well, guess what 90 minus 16 is? 74. So you know what? We might be doing something right there. Let's just double check here. Um, so the cos of 53, since we're in CAST, yeah, it should be positive, so that looks okay. But let's look at the cos of 74. Let's look at, yeah, the cos of 74. Let's just double check that this is right. It should cos of an angle. Yeah, we have that plus sign, right? But wait a second. Is the cos of 74 the same as cos of 106? Do those give us the same answer? No, because the cos of 76 should give us a negative. So there really should be a negative sign there to account for that. So this one was really tricky. It was just about right, but it's not really the cos of 74 that goes there. It should be negative the cos of 74 to give us our 53 and our 106. Okay, that one was pretty tricky. So no, not true. Close to true, but not quite. So these might be questions that come up on a departmental where there's multiple choice. The other way you could easily check this is just putting in your calculator. Does the cos of 53, the decimal that spits out, is that the same as the decimal that spits out here? Okay, next one. Is the tan of 185 equal to sine 10 over 1 plus cos of 10? Okay, so once again, let's look at 185 times 2 is going to be 370 degrees. So that is somewhere over here, 370, with a reference of 10, right? Because 360 and another 10 is 10. So 300 and, yeah, like they would all be positive. They'd all be the same sign, right? Because 10 would give you positive because it's in this quadrant, and so would 370. So that's looking okay. Let's just double check they actually copied the identity right. So we have sine 10, 1 plus cos 10. So tangent sine 1 plus cos. Yep, they copied the expression correctly. So yes, this is true. Okay, so you've got 2 days to work on this. Make sure you have your formula sheet in front of you. Make sure you're thinking about where the angle is, reference angles, you're talking about looking at the signs, all of that sort of stuff.